Welcome to today's Explainer. We're doing something a little bit different and, honestly, incredibly fascinating today. We're taking a highly technical 16-page catalog of raw electrical components, the kind of document literally only industry professionals usually look at, and we're transforming the whole thing into a dynamic, guided tour of a master electrician's toolkit. By the end of our time together, you're going to see the built environment around you in a completely new light. Okay, let's dive right in. Because before we can even begin to understand what goes inside the walls of your home or office, we absolutely have to understand the specific gear required to put it there, right? An electrician's bag isn't just a jumble of metal, it's a highly curated collection of problem-solving instruments. So here's our map for today's tour. First up, essential hand tools. Second, specialized electrical equipment. Third, PVC and domestic materials. Fourth, metal conduit and accessories. And finally, number 5, cables, fixings, and connectors. Section 1. Essential hand tools, the basics and beyond. Looking at the core hand tools, you'll immediately recognize the screwdrivers and pliers. But, and this is a big but, an electrician doesn't just grab any off-the-shelf screwdriver from a discount bin. Precision literally equals safety in electrical work, which means they need highly specific profiles for highly specific jobs. Notice the highly specialized design here. Take the stubby pause drive, for instance. It's tiny, right? It's designed specifically to solve that incredibly common problem of cramped spaces inside small electrical boxes, where a standard handle just won't fit. Then look at the parallel tip slotted screwdriver. Unlike a standard flared flathead, the blade here is exactly the same width as the shaft. Why does that matter? Well, because it is meticulously designed to sink deep into an electrical terminal block without catching on the plastic sides, and crucially, without stripping those tiny terminal screws. It's all about absolute precision. Shifting focus, we move from finesse to the heavy hitters. Now, you might not associate hammering with delicate electrical work, but it's vital. We've got a real contrast here. First, the ball-peen hammer, utilizing its rounded ends specifically to shape and tap metal enclosures. And right below it, the lump or club hammer. It's basically a miniature sledgehammer used with a chisel to aggressively chop out channels in brick and block work for socket boxes. It's the brute force that precedes all that delicate wiring. Moving on to Section 2, Specialized Electrical Equipment, the Secret Arsenal. Check out that tool with the colored handles. That's a crimping tool. And let me tell you, it is not just a glorified pair of pliers. It's a true precision instrument designed to completely eliminate human error. So the absolutely crucial point here is in the definition. Loose electrical connections start fires, period. To prevent that, this tool has an internal ratchet mechanism. When an electrician squeezes the handles to crimp a metal connector onto a wire, the tool physically locks. The ingenious mechanical failsafe of the ratchet guarantees it will not release until the absolute perfect amount of pressure has been applied. You get a completely secure factory-grade connection every single time, regardless of how tired the electrician's hands might be. It's a real game changer. Now think about that bright orange coil. That's fish tape or draw wire. It is the ultimate problem solver. I mean, imagine you have 50 feet of empty plastic tubing snaking through the walls and ceilings of a house. How on earth do you push a floppy, flexible copper wire through that? You don't. You push this stiff, springy, metal fish tape all the way through first, hook your cable to the end, and then magically draw the cables back through those impossibly long runs of conduit. Let's see how this builds into metalwork. Here we have the slightly arcane-looking M20 and M25 conduit stock and die set. When electricians are using heavy steel pipes, they can't just glue them together. They actually have to cut custom threads into the metal pipes right there on the construction site. It breaks down into 3 active steps: holding the stock tool, using the inserted die to carve those sharp external threads into the steel, and manually rotating it using some serious elbow grease. This lets them custom build a steel skeleton for the wiring that's perfectly tailored to the building. All right, Section 3, PVC and domestic materials, the building blocks. We are now officially entering the world of materials. These are the permanent installations that you interact with, or at least rely on, every single day without even realizing it. You are looking at the consumer unit with a 100-amp DIN mounting isolator right alongside those MCBs, which stands for miniature circuit breakers. This isn't just some plastic box. This forms the vital command center of a home's power. Electricity enters here, gets isolated safely by the main switch, and is then meticulously divided into safe, manageable chunks by those breakers to power your lights, your fridge, your outlets, the whole 9 yards.
Section 4. Metal conduit and accessories. Industrial strength.
This brilliantly illustrates the vast difference in structural needs. On one side, we've got standard 20mm PVC conduit. It's lightweight, it's easy to cut, glue together, and perfect for the domestic use of a quiet home. On the flip side, we have metal conduit. Heavy duty, joined with heavy galvanized boxes, relying on those threaded mechanical connections we talked about a minute ago. Different environments, think a bustling factory floor versus your living room, demand vastly different structural protection for the live wires inside.
To make that metal system work, you need parts, a lot of them. Notice the sheer variety of metal fittings required, from brass female bushes to heavy steel lock nuts and threaded nipples. Commercial wiring isn't just pulling cables, it is a complex structural puzzle. An electrician kind of has to act like a pipe fitter, ensuring every single mechanical connection is tight, secure, and electrically continuous. Why? So that if a fault happens, the metal pipe itself acts as a safe path to the ground.
Which brings us to Section 5, cables, fixings, and connectors, tying it all together. Let's demystify what often looks like a total alphabet soup of cables. An electrician basically scales their approach based on the threat level. For standard domestic circuits, the gray PVC flat wiring is perfect. But say you need to bury a line underground. You switch to PVC/SWA/PVC, steel wire armored cable, wrapped in a literal shield of steel. Need an alarm system to keep working while the building is actively on fire? You use FP200, a highly specialized fire performance cable. And for the ultimate, practically indestructible power line in extreme commercial sites, you use MICC. That's a copper tube packed with mineral insulation that can literally survive being smashed and burned and still carry current safely. Unbelievable, right?
But hey, none of those cables mean anything if they fall out of the ceiling. Enter the dizzying array of tiny, crucial fasteners that truly keep a building from falling apart. Let's do a rapid-fire rundown to just convey the massive variety here. We've got open grommets protecting cables from sharp metal edges, pop rivets permanently binding metal trunking, nylon plugs expanding inside brick walls to grip screws incredibly tight. It's a massive variety of tiny parts required on every single job site, and the electrician has to know exactly which one to use in a split second. We finish our toolkit tour by looking at where the heavy-duty power finally exits the wall. Enter the commando plugs. Far larger than the plug on your toaster, these beasts are capable of handling massive 3-phase 400-volt power. They are color-coded, ruggedized, and lock securely to power heavy factory machinery or massive concert lighting rigs safely. And that brings us to the end of today's explainer. We've gone all the way from the specialized tip of a terminal screwdriver to the rugged threads of steel conduit, right up to heavy industrial commando plugs. So I'll leave you with this. Next time you walk into a room and simply flip a light switch, will you look at it differently? Knowing the complex web of specialized tools, fail-safe ratchets, and heavy-duty materials secretly working together right behind the paint to bring you that light. I really hope so. Keep learning, keep questioning, and I'll catch you on the next explainer.